My guest today is Professor Missy Cummings, who's Professor of Engineering and Computer Science at George Mason University. She is also the director of Mason's Autonomy and Robotics Center. Welcome, Missy.
Thank you for having me. It's good to be back.
Yeah, I should say welcome back. Yeah. We talked, I guess, 3 years ago, 4 years ago, perhaps.
Yeah, it's been a while.
Yeah. And a lot of things have changed. Elections, autonomous vehicles, all sorts of stuff happening. And we'll talk a little bit about that. So I want to start with something a little different, though. So this is one of your latest papers, but I don't know if it has been gone through peer review and published. But it's entitled "An Interactive Decision Support Tool for Real-Time In-Flight Replanning of Autonomous Vehicles." You see here there is significant interest in the Department of Defense to design and build networks of unmanned vehicles that will have the ability to operating autonomously, which will in effect take the human out of the loop at certain levels of tasking. While unmanned systems do not necessarily have a human in direct manual control, humans will be necessarily involved in planning higher level operation and contingency interventions. There's a system of command and control. Unmanned vehicles is still a manned system. Yeah, I quite like this, Missy. So this is a sort of specialization issue here. I mean, machines are actually sometimes pretty good in tactical decision making. Humans take a little bit more time sometimes under stress or under other parameters that are not fully controllable. But then humans are pretty good to look at sort of strategically what needs to be done or what needs to be corrected, right? So this is sort of combining sort of tactical operations with strategic planning. Is that the way to think about it?
Yeah, I think we got to be careful not to make too many sweeping statements like AI/computers are always good at tactical making and humans are always good at
Mm,
strategic decision making. I think that there are elements of truth in both of those. But for example, humans can be very good at recognizing very quickly when something isn't right
yeah.
on the battlefield, and they may be able to have, we might call it intuition, and to hold fire, for example, when a
Hmm.
robot would just be strictly going off the information that collected, and maybe it doesn't have the same sense, if you will, that something is wrong, and maybe would
Mm,
not take that into account. And consequently, humans don't always make the best strategic decisions. We see this over and over again, no matter how much time some humans plan and how much
mm,
information they have to make a plan, they will come up with a good plan. This whole flooding situation in Kerrville, I'm sorry, in Texas,
in Texas, yeah.
has been just maddening to me
Mm.
because I hear over and over again, yeah, we call it flooding alley. I'm like, well,
Right.
if we're
Yeah.
calling something and we've been calling it that for years, why on God's green earth did we ever think it was a good idea to ever put camps for kids there ever? Like, so that's a really good example. Well, our strategic planning as humans really failed in that
Yes.
in that way.
Yeah, I read something, Missy. Like, so the Mystic Camp, I guess that's what it's called. The owner of that has been talking about floods that are going to destroy us for like 10 years, and he got killed in this flood, which is
I
an ironic situation. Yeah.
Yeah, I mean, I don't mean to be mean, but I mean, all those children did not deserve to die. There's actually, it's just, it is, he's not going to live to see the lawsuits, which I think is
Mm.
unfortunate. But I just think that we need to, and I generally like to move people off of the either or. This is true for Department of Defense Systems. It's
Mm.
also true for generative AI, which is new since the last time we spoke.
Yeah.
Generative AI has exploded on the scene, and I get really exhausted with people trying to compare, like, humans are better at this and machines are better at this, when
Mm.
in fact we need to look at the joint space. Indeed,
Mm.
self-driving cars, which have matured a little bit since we spoke last, but
Yeah.
not as much as you would have as
Yeah.
much as you would have thought that they did. Waymo makes these ridiculous claims over and over again
Mm.
that their cars are safer than humans. But what they don't want you to know is that in a lot of cases, for some cars, but indeed for all cars, um, they're all getting some level of human supervision, and in some cases, multiple people.
Mm.
So, and they like to say, well, our cars are safer than average human drivers. I'm like, whoa, whoa, whoa. That is not a fair comparison. Like,
There are two drivers in there. There's a
yeah,
machine driving and there's a human.
at the very least, like, and sometimes there's like three, like, so I mean, you and I are not driving to the grocery store with three people watching everything that they do out of all the cameras. And if we had a whole NASCAR team of people
Mm.
watching everything that we did, we'd probably be safer drivers too.
Mm.
So
Uh,
yeah, I just think that I think we need to be,
yeah.
Waymo is correct in that they have elected to have a human autonomy team to do the best task.
Yeah.
So I think that they need to lean into the collaboration instead of trying to punish humans.
Yeah. Going back to the autonomous flying modality. So you're in a unique position, Missy. I mean, you're one of the first understand naval fighter pilots in the U.S. Navy.
Female fighter
And
pilots. I'm not that old.
all right. So you bring sort of practice into theory in some way, and in sometimes you're missing it. So we do a little bit of the stuff in the industry, Missy. So I want to get your perspective. So I was in a large pharmaceutical company in the 90s, and we were investing $4.5 billion in R&D programs. There's a lot of data, a lot of uncertainty, 400 different R&D programs running. There was no easy way to allocate resources, people, time, space, and money into R&D programs. So what we did was to sort of analogous to what you're saying here is let the machine sort of optimize, give us some guidance, and at that point let the humans take over, apply intuition, apply experience, and make the decisions better. Obviously, the physical modalities are quite different, but it's sort of analogous, right?
Yeah, I think that's a really good assessment. We when I teach about this, I teach that machine slash computer slash AI are really good at repetitive tasks that don't have a lot of uncertainty. Math computations, as long as you're leaving out large language models, routine tasks that have to be executed over and over again very precisely, like on an automated manufacturing line. And indeed, that work can be very, I would say, uh, it really diminishes the human spirit. This is what we see on factory floors. Like,
Hmm.
nobody needs to be doing the same task over and over and over again on a factory floor. That
Machines are
is
awesome. Machines are awesome
right,
at it. Yeah.
exactly,
Yeah.
exactly. And that is not meaningful human work. And I think that we should try to the greatest extent possible to use machines, computers, and robots to get rid of not only work that is not meaningful, but it is also dangerous. Like,
Yeah.
anything on a factory floor that requires the same human motion means that that person is going to suffer from a repetitive stress injury later in
Yeah.
life.
Yeah.
And no one wants that. And so I think that we need to step back and quit talking about replacement in the way that we do now and talk about
Hmm.
how can we do job task design, for example, so that we get the best of humans and the best of machines so that we can improve not just a product, which no one, everyone wants high quality products. But if you also can improve the experience such that humans are happy to come to work, then job happiness, absenteeism, people are happy to come to work, and then you don't have to worry about turnover rates, and you're able to really keep maybe smaller, but also happier and also more stable workforce.
Yeah, so I would say, Missy, that two worst words in English language, I would argue, is artificial intelligence. Um, because what we're talking about is really automation. It started with the advent of computers, industrial automation. This is sort of a progression of automation. And as you say, yeah, I mean, if it's repetitive, machines, we can automate machines to do it. I understand there is an Italian, I think in Milan, a Fiat plant that had only three people in the plant. Everything is done by machines. And those three people have a lot of responsibility, obviously, walking around. But I think this use of this term artificial intelligence, I think, is misplaced in my view. What do you think about that?
Oh yeah, AI is artificial but not intelligent. Yeah, so but I mean, it's a phrase that has become its own entity. So you and I are not going to be able to change that as much as we might want to complain. I think I get really concerned and am really concerned about how much people have decided, even people who should know better,
Hmm.
that agentic AI is all the rage. And I hear this all the time from my students that they all believe, or a significant number believe, that we're moving into a period of commerce where you have single human billion-dollar companies. That's all they want, because they think that AI and robots can do so much now that you never have to have a human, that you can make not even a million. I love their optimism. I'm going
Hmm.
for $1 billion and not have any employees.
Yeah, so
Okay.
Mark Cuban, sorry to interrupt, Missy. Mark
Yeah.
Cuban just said this recently. The the next trillionaire is a dude in the basement. Well, he's not very uh, gender
Right.
equal. But yeah, so the dude in the basement is going to be the next trillionaire, he said. I think this is an over optimistic view in many ways. Yeah.
Yeah. Mark Cuban needs to come hang out with me for 1 week, and both to get his archaic attitudes about gender, but also his understandings about AI. I get it. I get why you want that. Look, I'm going to be honest. If I have to go to a gas station and it involves interacting with a human, I won't go. If I can't pay at the pump,
Yes.
it's same at a
Yes.
grocery store. If I have to interface with a checker, I'm
Yeah.
not doing it. So I get it, because we're trying to streamline our lives, but we're talking about pumping gas and getting my groceries. This does not require a lot of intense skill. And
Completely automatable.
right,
Completely automatable.
exactly,
Yeah.
exactly. Yes, all the reason why the elevator operator is gone. But who
Yes.
but what drives me crazy about where we are in tech in the world today, and in this point in history, is that people are running around claiming that generative AI spells the end of coding. The people who claim that
Yeah.
don't code and don't use Gen AI in any, I just have to, I
Yeah.
just laugh. You clearly haven't done it. You clearly haven't tried to do it. And is it possible that Gen AI might be assistive for coding? It might be possible, but every study
Mhm.
that is coming out is showing and I've done studies and we're publishing it ourselves,
Mhm.
coding, you can get code, but what you're going to do if you get code from Gen AI is you're just going to spend more time debugging that code than
Yeah.
you're going to spend in had you not coded it yourself. This has become so such a problem now that companies are starting to ban the use of Gen AI in coding because
Yeah.
they're starting to realize it's costing them too much to rely on Gen AI code.
It's really puzzling, Missy. So I think Mark Zuckerberg said we won't need any programmers very soon. I mean, this is a guy who has been involved in this thing for a long time, so he should know something. And he's paying $100 million in signing bonus to folks from another company. Um, he should know something. I mean, I feel like I'm missing something. My intuition is exactly yours, but I wondered if both of us are missing something. Did we miss a wave that we didn't quite understand?
Well, first of all, I would like to point out that, I appreciate what Mark Zuckerberg did when he was young, but I believe that for all of these mega CEOs, there's a tipping point where they go from grounded individual to rich, crazy person. And I feel like that his conception of the metaverse was a signal to the world that he had moved into that tipping point and he went crazy. And certainly all the data, I've been saying this for years, and the data definitely supports me on this. No one is in the metaverse. No one ever was going to be in the metaverse. This was 100% predictable, yet he wasted billions of dollars inside the metaverse. He's trying to raise Google Glass from the dead. He is going to find out what every other person who's ever done this has found out, that
Yeah.
that's not, that is a flying pig. And so I don't care whether Mark Zuckerberg, I'll never have as much money than him. Uh,
It's just a matter of
but
time, Missy. Just a matter
oh,
of time.
but trust me, I'm just not, because I say what I think, and that's gonna, I'm a woman, so I'm not gonna get there, Gil. But I do think that he's lost touch with reality,
Hmm.
and anyone again, he's not working with Gen AI. If he were spending any time trying to code with Gen AI, he would have said, maybe we should work on this before we make any big claims.
Hmm.
I think the other thing you can't rule out is he actually does know, but he's so desperate to sell whatever Gen AI related product that they have,
Yeah.
that he's just going to lie to everyone, even though he knows full well that these technologies will never fly. And I don't know about him, but I certainly get the sense from many other Gen AI
Hmm.
related companies,
Hmm.
they do know, but they're desperate to recoup their losses.
Yeah. I mean, his CTO, a professor at Columbia, Jan, can't remember his
LeCun,
last.
Jan
Yeah.
LeCun. Mhm.
And he says the right thing. He said, this thing is not going to go anywhere. I mean, he said two things. If you're a startup, stop LLM, Gen AI stuff, because these four guys have so much money, they're going to steamroll you. So this is not something that any startup can go anywhere with. But he's also saying that language is linear, so it's actually an easier solved problem, LLM, a stochastic parrot, I would argue, assign a probability for the next word. But thoughts, video, stuff like that are not linear that way. So this is not an extensible technology into knowledge and intelligence. This is just it's a better word perfect. Let me put it that way. But there are trillions of dollars going into it, which puzzles me. Yeah.
No, now look, don't bring word perfect into this. I miss word perfect. That is that is one piece of software that I would love to bring back. But yes, I totally
With the
get your
blue
point.
screen and the white letters and everything.
Oh my gosh, I just loved, and you know, I don't even want to start down the path of why I hate Microsoft Word and all the things. You know, I was a Word perfect believer. And so, um, but you're just as totally right. I think what happens for these CEOs, I think Zuckerberg has fallen into this. Sam Altman will fall into this.
I
Uh,
think it's already fallen. Yeah, I
yeah, I
think.
mean,
Yeah.
the fact of the matter is that they had this first amazing big win,
Hmm.
and they had the big wins because the time was right, the product was right, America's reception to whatever the product was right, and it really becomes, you know, a cultural behemoth.
Hmm.
But then what has happened with I was say, but then I think they are desperate to try to recapture that big win.
They
They're
need
not,
new products. They
that's
need
right.
new products. Yeah.
They're never satisfied with the one big win they had. They want to have
Yeah.
two, three, four, five. And I heard some podcast, I forget which one, that talks about, yep, nobody ever has the second big win. And, you know, I mean, it is what it is. And this is where I was going to bring in OpenAI. So Sam Altman's big win was just getting this to a place that the public just loved tinkering with,
Hmm.
this idea that you could have a conversation that
Yeah.
mimicked a real conversation, even though it wasn't a real conversation, and it could be
Right.
fun to play with. And I personally use a lot of large language models in my own
Hmm.
research when
Hmm.
I'm trying to model human opinions, because it's
Hmm.
really good at creating. That's what it means to be generative AI. Terrible at facting. You know, it
Hmm.
can't do facts, it can't do math, at least not reliably. And so this is actually where Sam Altman, he had a big win. It is not trivial that he was able to get OpenAI to a place where they were starting to roll out
Hmm.
chat functions that had the abilities to do what they did.
Yeah.
Where he really, his downfall was not living in that moment,
Hmm.
trying to then springboard it into some kind of product.
Hmm.
Now he's made so many promises, he can't keep them. It's just not possible, and the
Yeah.
world is catching on very quickly.
So I don't I don't use ChatGPT consciously. So it's an MIT study that came out that looked at three cohorts of people: frequent ChatGPT users, and sort of, I think it is sort of midterm, and then people who don't use ChatGPT. What they find in the brain scans of frequent ChatGPT users, this MIT study that just came out last week, the brain activity declines substantially, and you get sort of lazy.
Yep.
It is in the sense that if I need to write an essay, I just prompt LLM, and then it's going to make it for me. A pretty good product. So so I was going to start a company, Missy. It's called Brain Removal Surgery LLC. And at some point, you don't need your brain anymore. You can just remove it. I mean, it's just uses 20% of your energy budget. I mean, why do you have it anymore?
Yeah. So, I mean, please don't do that. Leave their brains in, because I'm being perfectly honest when I say this. I kind of love the insanity that is going around right now about what people think LLMs can do. Because I have a very small expert witness consulting business, which I am actually looking to scale up. And I've actually got external investors. And, I mean, I'm give me a few months to get my act together.
Yeah.
And I am really counting on people killing other people with large language models, Gen AI, agentic AI. And I'm going to put my daughter through college on this money. So don't go, don't, don't be,
No, no, no,
don't
no.
warn people. I want them to find out. No, I'm just kidding. Oh, I mean, I really am doing this,
Yeah.
but I warn people all the time, like you must babysit everything that comes out of generative AI. I call this adventures in babysitting.
Mm,
Sure, use the tools, but 100% you have to check every single output. And this is why it does
mm.
not become a labor saver. In fact, it's a labor coster because you have to look at every single output to make sure that it didn't hallucinate inside whatever application you're using it in. And this
Yeah.
goes to your point about laziness. The
Yeah. So
lazy people don't do that.
yeah, so it's a good segue to your other next paper, assessing LLM code generation quality through path planning tasks. So this is a very interesting experiment. So you say here, as LLM generated code grows in popularity, more evaluation is needed to assess the risks of using such tools, especially for safety critical applications such as path planning. But as you say, it might also be a cost increasing tool rather than a cost saving tool. But that jury's out on that still. So you say the existing coding benchmarks are insufficient as they do not reflect the context and complexity of safety critical applications. So you look at six different LLMs, I understand, right? The most popular six. And you gave them a very defined problem, this is an optimization problem, go from X to Y.
Yep.
And there are different algorithms. There are many, many different algorithms, but you pick three to just sort of look at what these LLMs are coming back with. Um, are these Python cards that are coming back with, or is it Python that they're coming
Yes,
back
yes.
with?
And that, well,
Yeah,
right. So the study that you're talking about, first we actually showed that you can't, people are who think that they can use any kind of large language model as a reasoning agent, we do see people frequently saying, oh, well, I can just use that to replace the robot brain and have it do the path planning.
hmm,
And so that first part of the paper, which was originally the paper that we tried to submit to a conference, I think, we got criticism that no one is stupid enough to use a large language model to path plan. And I was like, you're wrong. Because as a robotics professor, I see it all the time. My students are like, well, I don't need to build a path planner. I'll just use a large language model. And so,
it's a very clean defined problem. It's a clean optimization problem. So why would you use LLM for that? I mean,
well, because you're lazy. It's funny that you say that, right? Because you are talking about a generation who is used to saying, look, I don't need to write this code from scratch. I can go to GitHub and get
yeah.
the code and then build from that. I'm not saying that that's a bad idea. Indeed, depending on the application, I will tell my students to go to GitHub, get some
Yeah.
code, don't waste their time.
Yeah.
But it's such a natural thought process for my students. I'll just go to GitHub and get the code.
Hmm.
So now you just replace GitHub with LLM. I'll just go to an LL, and now, now that vibe coding is a thing where you don't even need to know how to code, you could just use an LLM, right? So it's just, it. I don't think all computer scientists understand just how
Hmm.
dangerous vibe coding is and how much thinking there is. Okay, so that was the first half of our paper to say, okay, if you're really not an expert and you want to try to use an LLM, here's how they perform if you if you think that they're reasoning agents. It's horrible.
Yeah.
Like, I mean, the answer, they can't do it. But then the next question was, okay, but what if you're a little bit more sophisticated and you're going to say, all right, I'm going to use them to generate the code
Hmm.
to um, code up the path planning.
Yeah.
then, and we use all the different LLMs, and we use 3 distinct different planners that they, by human views, are increasing in complexity.
Yeah.
But and I picked the planners on purpose. We picked Dijkstra's, Voronoi, and rapidly expanding randomized trees because in that order, humans think that they're more complex. But
Hmm.
I knew that there's just not that much research. Voronoi are a good academic algorithm, kind of to implement in practice. And so I had a strong suspicion, which is borne out by the results, which was the Dijkstra's code that was generated by the algorithms or by the different LLMs was pretty good.
Hmm.
Not great. I mean, it still needed to be tuned by a human, but it was okay. The RRT code needed more human effort, but still was kind of what I would say in the ballpark.
Hmm.
And the Voronoi code was it's not even in the same universe. And it just goes to show you that how reliant on the training data
Hmm.
these algorithms are, because Voronoi is not represented very well in any of the training data used by any of
Hmm.
the LLMs. They couldn't replicate it. And I will tell you, there is a secret finding in this paper that we did not print for all kinds of reasons. But I will tell you and the listeners of this podcast, unquestionably, this is going to surprise a lot of people. Unquestionably, the best coder of all the LLMs is Grok.
Yeah, I think you have it in the paper. I found it really interesting.
Well, I mean, we say
Yeah.
that, but what I'm about to tell you next is what we
Yeah.
don't say. I believe the reason that Grok is the best is because Musk is allowing Grok to train on the code from Tesla, from
Uh-huh.
Neuralink,
Okay. So they have some
from
proprietary
SpaceX.
information other LLMs don't have.
Yes.
Right.
Yes, because the code that Musk is generating in his company is recent code, very sophisticated code. He does have some of the best coders in the
Hmm.
country working for him. So I believe, and there are ways that you can backdoor this to find out. This is where you get in trouble with large language models. What
Hmm.
can you reverse engineer? So I do think that Musk has opened himself up to even more criticism
Hmm.
because it is likely that if that's true, that you could actually go back and back out proprietary code that you wouldn't otherwise have access to.
Yeah. So recent DeepSeek, as you know, seem to have trained their engines on whatever. I mean, it says what we used to call over the top LLM. Now, this is an over the top LLM. So if I have 6 LLMs out there doing all sorts of interesting things, I just put a layer on top of it and I will get something really interesting because, if I have some sort of rating system or some sort of voting mechanism, I can I can create something without a lot of money. I think it seems like that's what DeepSeek did. I don't know. I mean, I'm just speculating here.
It's again, it's hard to know for sure. I have heard that, and I wouldn't be surprised. I just don't. It, it without having insider knowledge about how any LLM is trained and what data it has access to, it's really hard to say for sure. One
Yeah.
of the things that and this is actually, why do I think this, that Grok has access to different data? Well, we see this, and if you read our paper, you'll see, oh yeah, it looks like it's doing something different. It is doing something tangibly different than the other LLMs are doing.
It's also a larger data set, I think, right?
Well, larger, but probably high quality. That what everyone else is doing is they're trawling the internet to get all the data that they need, right? And so and there has been a lot of discussion about this recently, and the more LLM generated BS you put on the internet, the worse all of these LLMs do because they're trawling the internet. But so
Right.
I think that they all basically perform in the same way because they're all grabbing the same bad, wonky data.
Mm,
This is why Grok is doing something different. It's
mm,
because it is not I'm not saying that it's not training on Twitter. I'm sure it is, but I think that they are actually being much more selective about
mm,
what data they are bringing in from the web. And I believe in terms of coding, they're using their own data, which is why
mm.
we see such high quality code that none of the other LLMs can represent.
That's really interesting. So is a Tesla code in Python as well? I don't know anything about this.
I've actually never seen Tesla code, so
Yeah,
I wouldn't know. I don't even know what language but Python is quite common.
yeah.
And even if they don't use a lot of Python, I suspect they're using something that's Python adjacent.
Python adjacent, yeah. I mean, it's clearly not .NET or anything like. I mean, they're not paying anybody to run it. So I want to go into another paper, Missy. So task configuration impacts annotation quality and model training performance in crowdsourced image segmentation. So you see here, many industrial image segmentation systems require training on large annotated data sets, but there's little standardization for producing training annotations. Data is often obtained via crowdsourcing, but many labeling task configurations are set by convenience and may have unintended effects on data quality. Yeah. So annotation here is I have a cat image and a dog image, and somebody went in there and said, this is a cat and there's a dog at the very high level. You say, I need a lot of it. So I'm going to crowdsource it. I'm going to, give somebody 50 cents to go through it, maybe in a developed, I don't know anything about it, maybe in a developing country or something. And you bring all this data together. There is no standardization, as you say, because everybody is sort of doing it differently. Um, Maybe there's a manual of some sort that they they ship to those places, but I'm not sure. So that's the issue, right? There's a lot of noise coming back from crowdsourcing. Is that the issue?
So in terms of the annotation issue,
Yeah,
the research that we've been working on has been showing that you've got to, if you're going to train, for example, to recognize cats and dogs inside the images, you've got to have tons of images that have the annotations done.
yeah.
And so indeed, there's companies like Scale.ai all over the world, companies that really focus on trying to annotate as much of this data as possible. It is universally recognized that human annotation data is the high standard
Yeah.
as long as people are careful. There's no annotation company that I know of that would disagree with that. So, but careful is a subjective word here, and it's also the key word. Humans hate annotating data.
Yeah.
And when we say annotating, just for the listeners, what we mean is that someone's drawing a careful outline around the edges of each part of the element so
Mm,
that you can put that image into a large neural net so it learns the patterns of what different images are.
mm.
So to that point, humans hate it. And if you force them to do it for long periods of time, which there are many companies that do that,
Yeah.
if you after 8 hours of annotating data,
Mm,
by the eighth hour, people are extremely sloppy, and they're often rewarded by the number of elements that they annotate in the image, the number of images they get done through the day. So they're really incentivized to speed through these things. So human annotations suffer from a lot of problems.
Yeah.
So people have tried to make computer-based annotations, like, oh, so we'll train some neural nets and they'll be able to annotate it. But the problem is neural nets only regress to the mean. So it turns out auto annotators are just as bad, if not worse, than human annotators, but in different ways. Either way, one of the things our research is showing is that if you rely on sloppy human annotations, which are almost all annotations, or you rely on auto segmenters to do the annotation, the cost to the neural net performance is around 15%. We showed this over and over and over again, that the cost to sloppy data is about a 15% at best drop in your neural net performance. And, you know, if this is you just having your face isn't being recognized correctly on your phone, that's not a big deal. But if it's a self-driving car that's trying to recognize the right objects in a scene, a 15% decrement is gigantic. So I think that where we're trying to move people to is, well, first of all, admission is half the battle. I feel like this is an Alcoholics Anonymous group that I'm talking to, like trying to get the community to admit in public what everyone knows is true is a huge problem, right? People don't want to admit that because if we had to admit that every neural net in a computer vision system was probably underperforming, that could really derail many, many, many different businesses. So we need people to admit it so that we can start benchmarking and giving realistic benchmarks. And one of the things that my student who just finished with his PhD is showing is we actually know that the worst part of being a lazy human is when you're doing an annotation, and let's say you're annotating somebody, the 5 fingers on your hand.
Yeah.
What you have to do is annotate around the thumb and then your fingers, and that pinky finger is so annoying because it's out there, it's a different size.
Takes a lot of time.
Yeah. And so what people will do is just kind of do a weird circle around it. Okay, this is what it looked. This is a hand. Or, you know, this is a pointer finger and this is a thumb, and that's all I care about. And then so when you cut off what we call spiky images, you know, anything with a protrusion, that spike that you cut off then is a critical part of the training that the system is missing. And thus, this is and one of the things you'll find out is computer vision systems are terrible at trying to understand hands. And that's because we're lazy at preparing the data.
Right, right. So, so I want to go to another papers, which is sort of related. So identifying research gaps with self-driving car data analysis. So we talked a little bit about this. So you say here there are currently around 30 companies testing self-driving cars in San Francisco, effectively creating a living laboratory. Of these companies, only Waymo, which I suspect is owned by Google.
Yeah, for Waymo, yes.
So only Waymo is engaged in commercial operations. I guess this changed. I think Tesla is doing something in Austin, Texas, I think, right? While Zoox conducts routine driverless testing operations in San Francisco. So despite the successes, federal investigations have been opened into both companies for safety concerns, and Cruise, which is Chevrolet.
I'm sorry. I hope you can cut that out. Sorry
Bless you.
about
No worries. Cruise is Chevrolet, is it?
Cruise is General Motors.
General Motors, yeah.
Yeah.
And Cruise is attempting to reinstate its permit after a near fatal pedestrian crash. So, yeah, I mean, for me, from afar, this is a lose-lose proposition in the sense that, yeah, you're never going to get perfect. And when you fail, it is very visible failure. And so the public is going to come down on you like a bag of rocks or whatever, right? I mean, we have 5,000 people dying on the roads every day in the US by humans. And humans are not very good at driving either in many ways. So, but this is a cosmetic problem in many ways, right? I mean, where do you fall on this?
Uh, so where do I fall on the problem of so humans are dying at the last numbers I think were around 34,000 a year. So it's not
34,000 a
5,000 a
year. Yeah.
day. Yeah, there's
Yeah.
something in that ballpark.
Yeah.
They peaked around the pandemic,
Yeah.
and so humans are bad drivers, and I do think that we need to do more to prevent that. I wish we would do more of what Toyota used to call the guardian concept. Let's
Hmm.
use AI to help keep people safe
Yeah.
as opposed to trying to replace the driver. And this kind of goes to what Waymo is doing now, which I
Hmm.
referred to before. Now, Waymo is claiming that they're safer than a driver,
Hmm.
a human driver, but that's actually not a fair comparison because
Hmm.
they've got a team of people supposedly in the Philippines who are remotely watching everything that
Oh,
a
wow.
self-driving
Okay.
car does
Oh,
to supposedly help it, which in above itself, like if it makes the car safer, I'm fine. So, but first of all,
that's
you
a
can't.
bit like cheating though.
Well,
If they
yeah,
don't, yeah, yeah.
it is the thing is, I don't mind that they cheat, but I mind when they say, "Oh, well, then this is the human, you can't those humans are pesky drivers, we're so much better." I'm like, "No, no, no, you can't have it both ways. You can't
Yeah.
have humans help and then say that humans are terrible drivers." So the reality is that none of these companies have actual self-driving
Yeah.
cars.
Yeah. Yeah.
They're all heavily assisted by humans. I would be okay with that, but I think the other big question that this leads to is it cost scalable? So if
Yeah.
it takes 1 to 3 people, which are estimates that I've heard,
Yeah.
if it takes 1 to 3 people to safely operate every self-driving car,
Hmm.
then just put the taxi cab driver back in. Like, I mean, that's what okay, so was that a good enough model
Hmm.
until this technology gets better? And, how do we get it to the point where it's cost effective to have no
Hmm.
one in that seat?
Hmm.
And I believe that it's probably going to be, we probably will get there one day where in narrow settings, in urban, well-mapped environments, self-driving cars without humans supervising them from the
Hmm.
Philippines is going to be okay. But one of the things that we've seen routinely, and there's no indication that there's any fix for this, is the
Hmm.
fact that Waymos right now cannot go on the interstate because they cannot handle highway speeds. And
Yeah.
for a number of reasons, but one of the big reasons is hallucinations.
Yeah.
So kind of tying in to back to Gen AI. So people hear a lot about hallucinations in generative AI, which means for GPT that it just makes mistakes. So
Yeah.
those aren't actually hallucinations. They're really just statistical inferencing errors. What's
Hmm.
really happening in self-driving cars are they are really no kidding having hallucinations.
Hmm.
They are seeing things that aren't there. And you can read
Yeah.
more about this in that paper. But
Yeah.
if the cars if they see things that aren't there at 65 miles an hour, then that causes the car to do an emergency hard brake.
Hmm.
And people have died because of this, not
Yeah.
not in Waymos, but in Teslas.
Yeah.
And so it is a huge problem. You cannot have thousands of cars just slamming on their brakes for no reason in the middle of the
Hmm.
highway. It becomes a huge public safety risk.
Yeah.
And we don't know how to solve that problem. We don't
Hmm.
know how to solve hallucinations. We don't know how to solve them in computer vision. We don't know how to solve them in large language models. Indeed, we could argue that in large language models, they're a feature, not a bug, because it's the hallucinatory element of large language models that makes them do creative things every now and then.
I don't know about that. Yeah.
Well, so, I mean, so it's the,
Yeah.
you've got to figure out like, okay, well, for a safety critical system like a car, we have got to fix it,
Yeah.
but we don't know how to fix it. So we're kind of stuck right now.
Yeah. So till an LLM tells me how to combine quantum mechanics with general theory of relativity, I'm not going to the creativity route at all.
I
I,
don't,
I,
yeah,
yeah. I
I
think it's
doubt
a
it.
stochastic parrot that assigns a probability for the next word, which is fantastic technology. But taking it any further from that, like a Nobel laureate, a recent Nobel laureate said, hey, you guys are all done. In 5 years, humanity will be wiped out by LLMs.
Yeah.
I hope not, but I mean,
Yes.
it seems a little bit far-fetched. Yeah.
Yes, I agree. I do not. I think those people are completely out to lunch, and again, they need to spend more time with the technology because if they spent any time at all, they would realize that that is not true.
Yeah. So I want to finish up with sort of a policy paper. So identifying AI hazards and responsibility gaps. And I think we have to spend more time on ethics. We have to spend more time on policy. So you see, with the expansion of AI in general, but especially in self-driving cars in the US, there's an increasing need for new hazard analysis approaches to determine if how AI contributes to accidents. As you say, the original Swiss cheese model, widely used for hazard analysis, focused uniquely on human activities that lead to accidents, but cannot address accidents where AI is a possible causal factor. So it's interesting. I mean, you were a Navy fighter pilot. We have autonomous things in the sky. I mean, we have had this commercial aircrafts, Boeing and Airbus. They're fairly autonomous. I think you just get it up from JFK into about 30,000 feet, and then you go to sleep, and it lands in Paris. Um, and it does pretty well, doesn't it? I mean, so why can't we? Well, it has another space dimension it can manipulate. I guess that's the difference.
People think that just because they think maybe autonomous aircraft are going to be more complicated than cars because they have the third dimension of altitude. But I'll tell you, that's actually more protective. That makes things simpler rather than harder. What makes driving so hard is that there's 50 other idiots just inches from you, and and that's not the case for flying unless maybe you're at JFK. But so I think that yes, do we have autonomy today? We do. The aircraft, I've written other papers that have shown that indeed pilots only touch the sticks anywhere from 3 to 7 minutes, period. That's it. For any
In a
average
7 hour flight.
7 hour, 27 hour, 70
Yeah,
minutes, it doesn't matter, right? Because it's only on takeoff. And
yeah, yeah.
that's because at the FAA has not certified automated takeoff yet, and that day will come. So yes, the autonomy, we do have autonomy. It is not, even in aviation, it does not perform well enough such that it doesn't need some babysitting.
Mm,
Certainly that's true for commercial aircraft, but even for military drones, there are a lot of humans that sit in ground control stations attending to them.
mm,
And even for the ones that in the Ukraine, the most recent impressive where they had them all embedded in the buildings and they came out at night, which is so impressive.
mm.
They were all teleoperated, meaning that humans flew all of them.
Yeah,
So, we still, this is where we are in 2025 is technology is great. It's improving a lot, but anywhere that there's a lot of uncertainty, we need a lot of human supervision. And
right.
we will get to the point one day, will we have passenger planes with no pilot? I will tell you
Mm,
the answer is technically we will probably achieve that.
Yeah.
Socially, we will probably never accept it because there's this thing called shared fate,
Yes.
which it's a concept where we only want somebody in the plane running the show who shares our fate. We're okay
Yes.
that the plane
Yes.
flies itself,
Yeah.
but we want a pilot, sort of pilot up there sharing our fate to do everything they can to save their lives and thus
Mm.
ours. So, we'll see about that. I do think that
But
within,
what does the statistic tell us? My understanding is that most of the crashes, airplane crashes, are related to pilot error,
yeah, over
not a machine.
80%. Yeah, over 80%.
80%.
Yeah.
And so that should push us in that direction, I would imagine, right?
Well, we're not rational creatures all the time. I,
Yeah.
I, but yes, that is true. Um, but we still, I call it, we like to have our baby blanket, which is the pilot in the plane with us, right, to make us feel better.
Yeah.
But I do think though that in my lifetime we will see completely autonomous FedEx and DHL planes.
Oh,
So
yeah, yeah,
and I think we need to think
yeah,
about that. We need to take one step at a time.
yeah,
And over water, overnight cargo planes, this makes a lot of sense.
absolutely.
So
Yeah.
so we need to, but one of the things that will have to change before that can even happen is we definitely need to modernize our air traffic control
Yeah.
infrastructure.
We're going backward.
Agreed.
Yeah, and all the drones, things that we have done, there's always a human behind it. Maybe someplace in central U.S. Um, and so even if commercial aircrafts become completely autonomous, there's still somebody who could be controlling it, right? So you don't need a pilot in the cockpit. I mean, that seems like a wasted resource in some ways, is where where I'm going. What do you think?
I so you're never going to be able to have a remote pilot for a commercial passenger plane. Uh, it sounds like that might be a good idea, but one of the reasons that it's not that great for cars, but especially not great for planes, are the latencies of communication
Yeah.
cause some very serious time delays.
Mm,
And there are some things that can happen on a plane that a pilot needs to attend to immediately, and there
mm,
can be no room for any kind of time delay because you are
mm,
flying over the North Pole, for example.
mm.
So I don't think there's ever a time in my lifetime. I'm not beyond that. I try not to make any predictions because
Yes.
I'll be dead. I don't think I don't think that the technology will be sufficient to take a pilot out, meaning even if you have Starlink, that doesn't
Mm.
necessarily mean that the satellite signal is high reliability. Nor
Uh,
is nor
yeah.
are the human passengers going to want to not have a pilot there.
Yeah,
So
I'm not getting on
yeah.
an airplane that is controlled by Starlink. I can tell you that.
Uh, well, Elon Musk hates me, so I 100% agree with you on that point.
Excellent. Yeah, this is great, Missy. Yeah, thanks so much for coming back on the show.
As always, it's so fun.
Thank you.
Thanks for having me.